Hi. Welcome. So this session is about orchestrating serverless, and by serverless, I'm specifically talking about Lambda, AWS Lambda, and so orchestrating Lambda with step functions. Now, if this were actually a Amazon talk, you'd see this say orchestrating AWS Lambda with AWS step functions because they want to make sure you remember that it's AWS. But we can be a little bit more wishy-washy here. So, are you ready to get started with this kind of technical presentation? Yeah, I think it's a pretty technical presentation. So we'll go ahead and get started. And I always like to start my presentations with selfies, because that's just fun. So this is me and my wife. We're standing on the Arno River, looking back at the Ponte Vecchio in Florence. It looks a little bit better on my screen. No, it's a pretty bad photo. I tend to wear a lot of tech t-shirts, although I'm in the Datadog uniform at the moment, so Datadog and slacks. Last year we went to Florence and we had an amazing time. It was so great. We stayed at a friend's house who has an apartment in Florence, which is amazing. Always a good thing to have is friends with apartments in really cool places. And then from there we drove out west to Tuscany, stayed at a agriturismo, and it was beautiful. Now, this was actually a photo that I took. I stepped out of my door and picked up my camera and took the photo, and that's what I saw. It was spectacular. Now, why do I start a presentation on serverless and step functions with selfies and beautiful shots of Tuscany? Well, it all comes down to a technology decision that I had made just before I went. A technology decision and a promise. And it feels like the microphone's still there, cool. So a technology decision and a promise. See, the promise that I made, it seemed like a good idea at the time. My wife said, you're not gonna take your laptop, are you? It's like, no, I'm not gonna take my laptop on vacation. I'm going to leave that at home and we're going to enjoy ourselves. We're gonna be together, it'll be lovely. And I've always traveled with my laptop. I've spent so many vacations hunched over that laptop doing whatever it is that I'm doing. But no, I made this promise that I was going to leave that home, but I thought one of the thoughts I had was I was going to update my blog. I have this New Year's resolution every year for the last, bazillion years, saying I'm going to have a blog that's kept up to date, that's going to be talking about cool things. And as you can see from this screenshot from a few months back, you only have to go back about 5 posts before you hit 2015. So I obviously don't do that very well. Now, how is this relevant? Well, I'd made a technology decision just before going to Florence. I had transitioned from a WordPress droplet on DigitalOcean to using Gatsby.js on Surge and then later S3. And those static site generators work a little bit differently from something like WordPress. So if I have my local machine, I'm doing my coding for a WordPress site, I'm going to find some sort of hosting provider to host my WordPress site, and then I'm going to push my content up to that server. And then the user is going to come along and make a request to my site. My site churns a little bit, thinks about the response, and sends back a response to that user. Great. How's that different with a static website generator? Well, you still have that server somewhere up in the cloud, although that server is not having to do quite as much because it just serves out static HTML, CSS, and JavaScript. And when it comes time to compile your site, your local machine does some churning and then pushes that static JavaScript, HTML, and CSS up onto that web server. And when the user comes along and makes a request, the server is able to respond almost instantaneously. But the problem is that local machine is doing all the work. It's generating the website. And I think I mentioned I left my laptop at home. And I don't really have a static site generator that works on my iPad or on my phone. So I needed to come up with a solution. So my name is Matt Williams. I'm an evangelist at Datadog. How many of you have heard of Datadog? Okay, so that's so cool. I've been at Datadog for about 4 years, and when I first started doing these presentations, well, not about this topic, but when I first started doing presentations at Datadog, you'd ask, and maybe like 2 or 3 people would raise their hands. So it's an amazing change. If you have any questions about this session, you can reach me on Twitter. I'm Technoevangelist, or email mattw@datadoghq.com, or you can check out my YouTube channel. That's a new thing I'm trying to do. I'm also an organizer for DevOpsDays Boston the last couple of years, and we're starting to get ready for 2019, and also running an event called Serverless Days Boston in next year. So if you happen to find yourself in Boston, it's a little ways away from here, but if you happen to find yourself just at the right time for those, we'd love to have you there. So I work for this company called Datadog. We're a SaaS-based monitoring and analytics firm. And we do infrastructure monitoring, we do APM, we do log aggregation. We've got this open source agent, and we're bringing in trillions of data points every single day. It's a huge amount of data that we're bringing in every single day. Now, if you find working on problems of large data sets, or selling that kind of solution, or marketing that kind of solution, if you find any of that interesting, we are always hiring, like pretty much every company that you're going to meet here over the course of the day. We're hiring, and we'd love to have you. We've got some great offices in New York City, and Boston, and Paris, and 16 other places all around the world. But that's enough about Datadog. I like to talk about serverless. This is me actually presenting at reInvent a couple of years ago.
And then we have a
right now I'm getting ready for my reInvent presentation this year. But if the screen were projector were a little bit better, you'd see the people wrap all around. There's like a second level. Oh my God, it was so cool. There were 2,000 people in the room. I love doing this stuff. So that was me talking about serverless, because I like to talk about Lambda. Now for a few of you who might not be familiar with what Lambda is all about serverless. Now, anytime somebody says that term, there's always going to be somebody in the room that says, that's a stupid term. Of course there's a server there. Ugh, why do people say it's serverless? There's a server there, and they're just idiots. Well, those people, sorry if you are one of those people, but those people are wrong. There is no server as far as you're concerned. You don't have to deal with the server. All you do is you write your bit of functionality, your function. If your company is in the business of generating widgets, you write a function that deals with widgets, and you don't have to deal with the server, patches, or any of that stuff. You just write your function. And you don't pay for idle. So you only pay for when your function is actually running, and it scales with ease. Now, it's function as a service, and you can write those functions in a variety of different languages. You can write it in Node.js, or Golang, or C#, or Python, or well, I guess that's about it on AWS. And it's trigger-based. Now, trigger-based is really important. And so the different triggers are here. Oh, they're over there too. I keep looking over here. So they're on both of these. So these are the different triggers that can trigger a Lambda, and so as soon as I add a file to S3, or as soon as I add a new thing gets added using CloudFormation, as soon as I say, hey Alexa, what is the blah, 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 that could trigger a Lambda. Lots of different things could trigger a Lambda to run. Now I like to show this diagram, not just because it shows my amazing abilities as a graphic designer, but because it shows the progression from physical boxes all the way to Lambda at the end. You know, we had these physical boxes, and we then wanted to take better advantage of these big boxes that we're buying. So we load up multiple virtual machines. We have these kind of process and security boundaries, and we can load up lots of different processes on these physical boxes using these virtual machines. Then we move these virtual machines up into the cloud, call them instances, and so that's really great, but we can't run a virtual machine in the virtual machine because most of those cloud providers don't let you do that. And along come containers, and we get some of the same benefits that we had of virtual machines on physical boxes, now with containers on instances. And along comes, a little bit later on, 3 years ago or so, we got Lambda. And now this becomes like the holy grail. Well, I get to focus on my stuff, on my widgets, or whatever it is, and I don't have to worry about all that other stuff, all the ops stuff. And normally, I would do a demo at this point. But I think you've seen enough demos of, here's how to create your first Lambda function. So I'm going to skip that. And hopefully I'm going, yes. But I do want to call out one thing that's really interesting. If you haven't seen the standard demo of how to create your first Lambda function, there are many presentations, including many that I have done myself, that show you how to do that. Or just sign up for an AWS account and try it yourself. It's really, really easy. But one thing I wanted to pull out was this. Now, a few years ago, up until about a year ago, if you had created a new Lambda function on AWS and then gone in to edit that Lambda function, you would have gotten a really ugly text box. I mean, not ugly, but didn't really do much. And that was where your code was. And you could edit it there, but it sucked. And that's kind of like the experience you get with Google today, and what you got with Microsoft pretty recently. But what I really like here is that this is Cloud9. So Cloud9 was this company that AWS acquired a few years ago, and now Cloud9 has become the default kind of editing experience inside of the Lambda console. And so that becomes really interesting. In fact, I can go into the full Cloud9 service and turn on dark mode because that's cool and sexy. And now I've got a great editing experience with Cloud9 of active Lambdas, and I can even do step-through debugging of my Lambdas. Super cool, but not really relevant to this. So Lambda's pretty cool, but it's not perfect. You still have to do a lot of stuff to configure yourself. If I've got a Lambda function and it's being triggered by an S3 file that shows up, I still have to go into S3 and configure that. If I'm doing it based off of DynamoDB or I'm storing stuff in DynamoDB, I still have to go into DynamoDB and set that up. Same thing with API Gateway. Now, there are plenty of tools out there to make that easier. There's a serverless application model, SAM, as well as CloudFormation for configuring all those other services. But I happen to like using serverless framework because that works really well for me. Now, I showed you this slide before. Again, beautiful. Oh, look at those different colors. That's obvious. There's some graphic design amazingness there. But it implies something that's not actually correct, because serverless is not the same as an EC2 instance. It's not even the same as an application, because applications are complicated, and serverless functions in general should respect something called the single responsibility principle. Now, in most cases, most times that I do a presentation like this or a presentation based on this, I show this, and there's a lot of glazed eyes, like, okay, what's that? And then about 6 months ago, I did a talk at Saturn, which is run by Carnegie Mellon University by their Software Engineering Institute. And all of them in the audience like, oh yeah, single responsibility principle, totally got it. Well, in case you're not familiar with what the single responsibility principle is, we can go to the source of all knowledge in the world, Wikipedia, and we see that single responsibility principle, in essence, is every function should do one thing. What is that one thing? Well, that's up to you to figure out. But generally, things, functions or methods or whatever should generally do one thing. And so that diagram that I showed you, that progression from physical boxes to Lambdas, maybe I should have done something more like this, where the container or the instance or the virtual machine is replaced by a bazillion different lambdas. Okay, so we can create a lot of serverless functions, but how do we get them to work together? How do we orchestrate them? How do we get them talking to each other? Well, there have been a lot of different solutions for doing this. There have been using Kinesis or SQS or DynamoDB to help to make that become like the traffic cop or the organizer, the orchestrator of all your serverless functions. In fact, Nordstrom came along and created Hello Retail as an example of how you might get all these different functions to work together, using Kinesis in the middle as that traffic cop. But this poses a bit of a problem because now all my lambdas have to know specifically about Kinesis, either writing information into Kinesis or writing or pulling information out or being triggered by Kinesis. There's this, it becomes a very brittle environment. If I need to change Kinesis to whatever is the new hotness next week, or when reInvent comes along in a month and a half, maybe they're going to release something amazing that they want to replace it with. That's going to be difficult. Of course, I think they are no longer on AWS and they've moved to Google, but hey, that's a different thing. So along comes step functions. Step functions are that they just make everything better, so much better. So here we've got a sample step function of, if you look at any introduction to Lambda, you're always going to see the demo of image processing. So here it is applied to step functions. And a step function is a state machine. And step functions have some basic concepts. There are a bunch of states, and the states include task and choice and parallel and pass and wait and all these other things. And there are transitions. We transition from one state to another, and there are executions. Actually, what you're paying for is the transition. So if you've got a complicated step function with a bunch of transitions, you're paying for each one of those. And that kind of freaks people out because, oh my God, I might have 10 or 15 or 20 and I have like a million executions. Oh my God, that's going to be crazy expensive. But you have to be getting into many millions of transitions before you start to see a couple bucks on your bill, on your monthly bill. So let's take a look at some of the different states that are available. There is a task. The task is the basic state. The task is you do something, and it's going to trigger a Lambda to do that thing. It can also trigger a step in your application on your EC2 as well, but generally it's going to be a Lambda. You can also have a choice. Maybe your first task generated, spat out a variable. In this case, it's saying foo is 1. And so if it's 1, go to first task. If it's 2, go to second task. And we're just having two choices, but we could have 1,000 choices. It'll make a really ugly diagram, but you could have 1,000 choices. Then you could say succeed or fail. And so when looking at all your step functions, if everything was, successfully went through the entire state machine, then you might think it's sometimes useful to say, yes, it goes all the way through, but it failed to produce the widget, even though it successfully failed to produce that widget. And so it's nice to see a success or fail in that list when looking at all of them in aggregate. You can have a pass. It's kind of a pass-through. Pass-throughs are great if you're just setting up the step function for the first time and you haven't built out all the lambdas. It's a nice placeholder. Or if there's one Lambda that is doing something weird, it's nice to have that pass through right in the middle to update the data the way you're expecting. Wait is super useful because I can wait for a timestamp, or wait for 30 seconds, or wait until 2 p.m., or wait until January 31st, whatever my time period is. And now I can, with Lambdas, typically there's a maximum length of time that a Lambda could run, which is up until about 2 weeks ago was set to 5 minutes. Now it's about 15 minutes. But you could have step functions made up of Lambdas that last 4 years or 5 years, for one single set of processes, because you can just have it wait a month or 2 months. We can have a parallel. So I run all these things, and I run all these things, and I run all these things. And when all of those are done, then continue with the next thing. So there are lots of different ways of building out step functions. I like to use the serverless framework because I just find it really useful. You just have to, if you're building out step functions, there's a plugin that you need to add. But the benefits of the serverless frameworks is that I can have everything in one place. I define everything one thing, and IAM role statements and function handlers and function triggers. I define all that stuff in one place. In one directory, there's probably 1 or 2 files, and that's it. Or more if you want. But I define everything in one place, and it's really, really easy. So at this point, oh, there's a question.
What's the serverless framework?
A serverless framework is it's a third-party framework from a company called Serverless. Serverless Incorporated, I think, is their company name. And it's just it's a utility for usually for creating Lambda functions, but you can have it create Lambda functions and other resources as well. Now, I want to talk to you about a demo that I gave a few months ago. And that demo was, it was really, really cool. Now, if you have to do a presentation for anybody, you do a presentation for your colleagues at work, or a presentation in front of 2,000 people, whatever you happen to be doing, demos you should try to keep demos as simple as possible. Simple demos are great because if something goes wrong, you can kind of gloss over it, pretend that you didn't actually mean to do that demo. Because if anything breaks, last thing you want to do is troubleshooting in front of all these people. This is a little bit more intimate, so maybe I could troubleshoot a little bit, but you still don't want to be doing much because when you've got a dozen people or more in front of you, you never think straight. So always try to keep it simple. Now the problem with keeping it simple is it is so damn boring. And so what I do for demos is something like this. These were all the tools that I used in my demo that I delivered at reInvent the first time and then a couple times since then. Now, my demo was I decided to live blog my session as I was delivering my session in front of, in that case, it was about 500 people. And so what I did was I had a Raspberry Pi camera sitting in the front row, and that was taking pictures every 30 seconds of my slides. And then posting that to API Gateway, which would hand it off to S3, which would start a step function, which would then take that image, post it to a third-party machine learning service. Now, ahead of time, I had generated 80 versions of each slide, so for a data set of about 5,000 images. Now, those 80 different images were randomly rotated slides in 3D space using image magic, putting a random background, because I didn't know about the space I'd be in, and changing the blur levels a bit. And then setting that, all of these 80s are slide 1, and then these are slide 2, and then these are slide 3. And so then that machine learning service would say, oh, well, if you hand me another image, I'll be able to tell you which slide you're on. And so I send it off to that service, and it responded, there's a 99.9999% chance that you are on slide 13. At that point, the next Lambda in my step function grabs the notes from DynamoDB, generates a markdown document, puts that in a different S3 bucket, which then triggers another a code build that runs a Docker container to launch Gatsby.js that generates a new website, including all these markdown documents, pushes that to another S3 bucket, runs, sets up CloudFront, destroys the caches, and sets it all up again. And yeah, that's about it. So that was a pretty cool demo. Unfortunately, just a few weeks after I delivered the demo, Vise.ai, the service in the middle, the service that kind of did the most important part, they sent me an email saying, yeah, that thing that you did in that demo, that was great. Thanks so much for doing that. We pivoted. We're no longer doing that. Sorry. I am so glad that happened after the demo and not before. But yeah, so I used all these things in my demo, and it was really, really cool. In fact, these were some of the step functions that I created to do this. And I thought I'd walk through just a few pieces of that process. And so here is the actual website. And it's still alive. It's SF, as in step functions, not San Francisco, but sf.technoevangelist.com. Technoevangelist is my domain name. And here you can see, I went to page 4 because, unfortunately, well, okay, so it recognized there's a 99.99999% chance that you're on slide 22. Unfortunately, most of the time it would say you're on slide 13, and I was actually on slide 16, but who cares? It was a neat concept. So anyway, let's look at my serverless YAML file. At the top, I say this is a service that's going to be called this thing, and I'm going to load up a bunch of plugins. Webpack, because I needed to, well, at the time I originally did this, AWS only supported Node.js 6.10, and I wanted the new cool sexy things like async await and, well, everything else. And so I needed Webpack, I needed pseudo parameters because I wanted to do some cool things with CloudFormation templates, and of course step functions because it was a step functions talk, so I kind of needed that. And then you go into provider, and the first thing you put in there is name AWS, because it says that serverless framework works well with AWS and Google and Azure, and yes, it totally supports those things. Except serverless framework becomes super useful when you add all these plugins. And how many plugins are there for AWS? There's like 2 or 3 dozen. How many plugins are there for Google? None. How many plugins are there for Azure? None. So it's really, really only useful for AWS. But then I can also put in my IAM role statements. So here's a few of my IAM role statements to give my Lambdas access to other things. And then I can start defining my Lambda functions. So I define all those. And then one of my Lambda functions will go ahead and start my step function. Now the step function actually goes through a process. It says, use the machine learning to figure out which slide I'm on. If it's different enough than the last one, then pull that information from Dynamo and then start building the site and then wait for it. Now, I mentioned that you could have a wait state. Well, the Gatsby.js website took about 1.5 minutes to build, but I don't want my Lambda to just sit there for 1.5 minutes. And so I'd have it wait 20 seconds. And then, is it done yet? OK, wait 20 seconds. Is it done yet? Wait 20 seconds. Is it done yet? And so forth. So one of my first things at the beginning was a task. It's a Lambda function, just figuring out which slide I'm on. And then if it's a new slide, it's going to spit out, oh, this was the input. So I was given a file name because I uploaded that image to S3. So I've given a file name and a bucket, and it responds with, here's the % chance that you're on whatever slide you're on. And so I've got another task that just says, what slide are you on? OK, cool. Is this a new slide? So pseudocode says, get information about last slide, get information about the current slide. Is it different? And if it's different, it says something like update site is true. These are just values that I put in there, whatever variables I wanted to write into my output. Let's fast forward a little bit. We've got another Lambda function that just generates a document. So generate the post text, pulling in that information from DynamoDB and writing it to S3. Got some other Lambda functions that just say, go ahead and start building the site. And the build site just says, go ahead and trigger code build to actually run. I don't know if any of you have heard of code build. It's this thing that's one of these, I mean, you look at all the lists of services on AWS, and there's 100 or 200 different services, most of which nobody really cares about. But code build is so cool. This allows you to run a Docker container, and you can run any Docker container. There's like 7 built-ins, but you can create any Docker container to do whatever you want. And it can do anything you want it to do. And you're given about 100 free minutes every single month, which is a pretty cool thing, that whatever you want to do with a Docker container, 100 free per month. Then I looked at Google, and Google offers pretty much the same thing, and they give you like 100 free minutes a day, which is better, but still. I was on AWS because it was an AWS event. So here's my code build. Looks like I am running out of time. So I do my build, and really there's only 3 commands here. I'm syncing S3 bucket, running the Gatsby build, and syncing that bucket again. So how about monitoring? I work for this monitoring company. You might have heard of it, called Datadog. How about monitoring with Lambda? Well, we monitor via logs for Lambda. And so you're basically writing a line to the logs with monitoring all in caps, pipe, time-sensitive Unix, epoch, pipe, the value, pipe, what kind of metric it is, a count or a histogram or something else, a name, and some tags. And you just write that to the logs. We're also going to collect all the standard Lambda metrics as well as the step function metrics. Now, one more thing I want to include here is I've been working on a step function recently at Datadog, we rolled out a learning platform. Free learning, and the best customer is well-trained customers. We're providing lots of free training. And I wanted to, as soon as somebody goes through a hands-on exercise, I wanted to not require them to do a test, but rather automatically evaluate whether they've done what we asked them to do. And so I've got a step function that goes through the process of validating that they're a known user, validating that it's coming from a good place, and then doing a bunch of checks. And in this case, it got to return check results and it errored out. And so what I can do is go into the Lambda console to figure out what just happened. And it gives me a little bit of a cryptic message about what just happened. So I want to get a little bit more detail. So I go into the the logs for the CloudWatch logs for this thing. I figure out which of these log streams I need to go into based on the time back here. I figure out where the time is, and then I come back here, find the right log stream, go in there, and look at the error message. But then I go to another one. Maybe I need to look at another Lambda. Now I need to go into a separate stream, and it's just a nightmare having to line these things up. And so it's really useful to have some sort of log aggregation tool. I'm using Datadog because, by the way, I work for Datadog. But you could use anything, whether it's Sumo Logic, they're exhibiting here, or whatever log aggregation tool you're using. Use something to show you all the logs in one place, because it will show you all the stupid things that you've been doing in your Lambdas that you ignored, like I ignored a bunch of errors. And you can click on this, see a little bit more information, and so forth. So a couple of things about Lambda and step functions. Logging and debugging is still a bit painful. Don't trust the step function when it says it's done. One thing I did was I triggered the step function. I kept waiting for it to be done, and it would say it was done, but it would say it's done. I would start doing something, and when it says it's done, it hasn't finished writing the output JSON, and so I would check something, and then it would break. And so I just have to really, when it says it's done, wait 10 milliseconds for it actually to be done. But this is generally the same no matter what you're using. Don't trust the input. Cold start is a thing, but it might not be as bad as you think. Cold start is a thing, but it might be better. It depends on your exact scenario. Cold start is this thing where you start a Lambda function, and it can take a little bit of time for the container that's actually holding that Lambda function to start up. And depending on what you're doing, that time period could be anywhere from 80 milliseconds to, if you're using Java, it could be 5 seconds or 6 seconds or longer. Every Lambda should be doing one thing, but granularity depends. So that's it. My name is Matt Williams. I'm an evangelist at Datadog. You can reach me all these places. Hopefully you're going to be in Boston for either DevOpsDays 2019 or Serverless Days 2019. And that brings me to the end. Thanks so much for coming.